I'm about to steal your authentication token in one line of JavaScript. Here's a standard login: username, password, login button. Authenticate with test credentials. Authentication successful. The token is doing its job. Let me grab some protected data to prove it. Works perfectly. Now open the Application tab in DevTools. There's our JWT sitting in lodging. Looks harmless. Now watch this. One line of code and I have the entire token. Every claim, every permission, the full credential your application trusts. In a real attack, the next line silently posts it to the attacker's server. Your users would never see a thing. No pop-up, no warning, session hijacked, account compromised. The whole thing happened with a single line of JavaScript. So how was that possible? Because of where the token was stored. Most tutorials tell you to drop JWTs into local storage. It's simple, it works. The token survives a page refresh, survives closing the browser. But storage has one property that makes it a security disaster. Any JavaScript running on the page can read everything in it. Any script, including ones you didn't write. All an attacker needs is a way to inject JavaScript into your app, a comment section that doesn't sanitize input, a search box that reflects user queries back into the page. Any user input rendered as HTML without escaping. This is an XSS attack, cross-site scripting. And when your tokens live in local storage, you're leaving the front door unlocked with a sign that says, "Tokens inside." So how do you fix it? Move the token out of JavaScript's reach entirely. Instead of sending the JWT in the response body and storing it client-side, have the server set it as an HttpOnly cookie. Here's the difference. Log in again, but this time the server sends the token as an HttpOnly cookie. See that HttpOnly flag in DevTools? It means JavaScript can't read or copy this cookie. The browser knows about it, includes it automatically with SameSite requests, but no script on the page can extract the value. Try running that same one-liner from earlier and there's nothing there. The token is invisible to JavaScript. Even if an attacker injects a script, they can't steal the credential itself. That said, and this matters, HttpOnly doesn't make XSS harmless. An attacker who can run JavaScript on your page can still make authenticated requests from the victim's browser, but they can't extract the token and use it from their own machine, which is a significant reduction in damage. Your authentication flow still works exactly the same. The browser handles the cookie silently, attaching it to every request without your front-end code ever touching it. But solving one problem introduced another. Cookies have their own attack vector, CSRF, cross-site request forgery. Think of it this way. The browser is handing your house key to anyone who knocks on the right door. Here's how it works. You're logged into a banking site using cookies. You open another tab and visit a phishing page from a sketchy email. That page creates a hidden form that submits a request to your real banking site. The browser, doing its job, attaches your cookie automatically. The server sees a valid cookie, thinks the request came from you, and processes it. You never clicked anything suspicious on the real site. Attack succeeds. Here's the fix. Set the SameSite attribute on your cookie. SameSite tells the browser not to send that cookie in cross-site contexts. Set it to strict, try that same phishing attack again, and the request fails with a 401. The browser saw the request coming from a different site and refused to attach the cookie. Attack blocked. For context, strict means the cookie never travels cross-site, period. Even clicking a link to your own site from an email would require re-authentication. Lax is slightly more permissive. If a user clicks a link to your site from Google, their cookie still travels with them and they stay logged in. But Lax still blocks cookies on form submissions and AJAX requests from other sites. For most apps, Lax is the practical default. Strict is the safer one. Everything we just built, HTTP, only cookies, same site flags, assumes one thing most developers think they already have handled: HTTPS. Without it, none of this matters. Without HTTPS, your tokens travel across the network like a postcard. Anyone along the route can read them. Same Wi-Fi at a coffee shop? A man-in-the-middle attack captures everything. Headers, cookies, the entire payload, all in clear text. Always use HTTPS in production. Enable HSTS headers so browsers refuse to downgrade the connection. This is the foundation every other layer sits on. The safest token is the one JavaScript never sees. Store it in an HTTP-only cookie so scripts can't reach it. Set SameSite so other sites can't abuse it. Run everything over HTTPS so nobody in between can read it. One line of JavaScript shouldn't be enough to compromise your entire authentication. And now it isn't. If this helped, hit like and share. Thanks for watching.